Hello, young physicists. Have you ever wondered why do we say, I worked so hard studying, but physics boldly says, nope, that's not work? Let's clear this up once and for all. In everyday life, work means effort, studying, running, or even worrying about exams. But in science, work means something very specific. It's all about energy transfer through force and displacement. If you push a wall all day long and it doesn't move even a millimeter, sorry, physics says zero work done. On the other hand, if you lift a book upward against gravity, now you've truly done scientific work because your force actually moved something. So remember, in physics, no motion means no work, even if you're sweating buckets. Now, when does physics actually agree that work is done? There are two golden conditions. First, a force, we'll call it F, must act on the object. Second, there must be displacement, we'll call it S, caused by that force. If you apply a force and nothing moves, F may exist but S is zero, so no work is done. And if something moves without any force acting, well, that's not work either. For example, when a bullock pulls a cart and it moves, both F and S exist, so work is done. But when you're just standing still holding a heavy bag, even though you're tired, S is zero, no displacement, so no work. Work only happens when force and motion team up together. Now let's get mathematical. When a constant force acts on an object and moves it through a distance, the amount of work done is found using this equation, W equals F multiplied by S. Here, W stands for work, measured in joules, symbol J. F stands for force, measured in newtons, symbol N. S stands for displacement, measured in meters, symbol M. So when 1 newton of force moves an object 1 meter, the work done is 1 joule. And remember, work is a scalar quantity, meaning it has magnitude but no direction. So next time you push a chair across the floor, you can proudly say, I just did a few joules of work. Alright, here's where direction makes the story interesting. If the force and displacement act in the same direction, the work done is positive. If the force acts opposite to displacement, the work done becomes negative. And if force is perpendicular to displacement, then no work is done at all. We express all of this neatly using W equals F multiplied by S multiplied by cosine theta. Let's spell it out. W is work, F is force, S is displacement, theta is the angle between the directions of force and displacement. So when theta is 0 degrees, cosine of 0 is 1, maximum work. When theta is 180 degrees, cosine of 180 is -1, negative work. And when theta is 90 degrees, cosine 90 is 0, 0 work. Direction really decides who's winning the energy game. Let's try a quick example to make this concrete. Suppose a force of 5 newtons moves an object 2 meters in the same direction. We'll use W equals F multiplied by S multiplied by cosine theta. Substitute the values. W equals 5 multiplied by 2 multiplied by cosine 0 degrees. Now, cosine 0 degrees equals 1. So, W equals 10 joules. Let's interpret. W is 10 joules, the work done F was 5 newtons, the applied force S was 2 meters, the displacement. Since force and motion are aligned, the work is positive. And since 1 joule equals 1 newton meter, everything checks out perfectly. So yes, every time you push your school bag across the table, you're literally doing 10 joules worth of science. Let's wrap this up with a simple truth. Work is the bridge between force and energy. Work tells us how much energy is transferred when a force causes a displacement. If energy is gained, work is positive. If energy is lost, work is negative. Remember the universal formula, W equals F multiplied by S multiplied by cosine theta, where W is work in joules, F is force in newtons, S is displacement in meters, and theta is the angle between them. So, every time you push, pull, lift, or move something, you're turning your energy into work done in physics size. And that's how effort becomes measurable energy transfer, the scientific definition of work. I hope you enjoyed this session, and remember, physics doesn't count how tired you are, only how far you move something. See you in the next class, where we'll uncover the next big idea, energy itself.